All right, as an engineer, I could not be more excited about this update. It's easy to miss, but hugely valuable. Now, added to the psych chart, look at this line right here, space SHR. And in addition to that, we have this shaded region right here as well. So what is this? In HVAKR, when you are modeling your system and you're actually configuring your cooling coils, outside air intake, you're setting up your HVAC system. Now you can open this up and you can see what the space sensible heat ratio is for the spaces served by the system, the ratio of sensible to total load present in this system, which means if you want your supply air that's entering your spaces ultimately to satisfy the exact set point that you have targeted, and in my case right here, it's at 74 degrees, 50% relative humidity, then you want your supply air to fall somewhere along this line. And for me right now, it's a little high. If I'm going to supply this into my spaces, then I'll probably end up just at the topmost bound of my humidity set point. Now, I'm looking at the system as a whole right now. If you go to a specific zone in the system, you see the same kind of information. So this is the supply air going to this zone. Here's my set point for that zone, and here's the space sensible heat ratio for this zone, right? And I'm not on this line, so it means I'm probably going to end up with slightly humid air in my spaces. If I expand this further, I can look at specific spaces inside this zone, and I have the same view, except this time, that space sensible heat ratio, it's coming off of the supply air entering the space, and it's showing me where the temperature set point actually ends up in this space. So from this supply air state of 55 saturated, following the space sensible heat ratio in this space, it's telling me, if you see right here, the actual condition ends up just north of 60% relative humidity. And 60% is the topmost bound of my space set point. If I look at another space here, then I'll see, I'm just right there on the edge. So this line right here is a huge engineering tool. It helps me understand what my off-coil temperature needs to be if I do in fact want to stay within my comfort range. So now I can go back to my system configuration and I can adjust this cooling coil temperature. And let's say, instead of bringing it all the way down to right about 47, which is what this space sensible heat ratio line implies, let's just bring it down to 50 and see where we end up. Now I'm at 50, and going into my spaces, it's still going to follow that slope, but it should get me right inside the comfort zone. So back to my zone level analysis. Yeah, following that slope, I'm going to end up right about there. And if I look at individual spaces, then yeah, this one nails it. Let's look at this one. Yeah, you can see that X right there. I've hit my dry bulb set point, and I didn't quite hit 50% humidity, but I'm still within my humidity tolerance. So I'm under 60% relative humidity. And so where do these things come from? This range you see right here, the shaded area, you can see it larger here. This shaded area is based on the space set points I have for the spaces within this system. That really just comes from my basis of design. So in space types, my target for cooling is 72 degrees, and I have a 2-degree tolerance on that. And then for humidity, I'm targeting 50 with a 10% tolerance on that. So that's how we create that comfort zone of acceptable indoor set point. And then from there, the space sensible heat ratio is really just looking at the loads for my spaces. It's taking the sensible, the latent, and determining the sensible to total ratio. So I can now use this view to determine if in cooling, this off-coil temperature is cool enough to actually satisfy the target conditions that I've specified. So it's just a line. That's really all that was added, but is immensely helpful in really dialing in my coil sizing and design. So check this out if you haven't noticed it already. And if you don't know what I'm talking about and why this is important, then check out some of my older videos. Particularly if you go to the HVAKR YouTube page, our channel, you can find playlists and HVAC 101. We put eyeballing it, but basic stuff here. And what you want to look for is proper system sizing, part 1 and part 2. That's going to explain why this sensible heat ratio line is so important to your overall system design. And we added that into HVAKR just to make your job even easier. So go check this out. And if you're already an HVAKR user, we make it super easy to find. When you back out, you can go to videos. We put all of our educational stuff right here in the HVAC 101 tab, and you'll see those 2 videos at the very top, proper system sizing. And so now it's embedded into the app, and I hope you guys enjoy. This is, to me, one of the smallest yet most valuable changes that we've made when it comes to just good engineering.